Question 15. So you need to recognise that you need to use quotient rule. And quotient rule is quoted in the formulae book. So we're told it. So I've just written that down just up here. So let's just write down things that we're told. So that's where that's come from. And we've also got this rather horrible looking thing. X minus 1. Right, okay, let's just go and differentiate each one. So that now gives us 8 cos 2x, and just a nice little bit of chain rule coming up. So it's going to give us root 2, then e root 2x minus 1. Right, let's just substitute it in, see what we come out with. Right, it's not going to look very nice, but actually it doesn't work out too badly. So we've got 8 cos 2x. Going to multiply that by this part. So e, and then we got this horrid looking thing just here, and then take away this part. So 4 sine 2x, and also make sure we multiply here. So we got root 2 e, so we got that root 2x minus 1. And all of that, don't forget, is to be divided by e root 2x minus 1, and that squared. Right, there's a nice easy bit of cancelling down that we can do, because look to see what's in common on both parts. So that is going to cancel with one of those, and also that up there. So let's just write where we've got to before we sort of jump on too far. So we've got 8 cos 2x, take away 4 times root 2, if I put the root 2 just there, sine 2x, and then it's still over root 2x minus 1. Now what we're interested in is when this is equal to 0. Well, when's it going to be equal to 0? It's going to be equal to 0 when the numerator is equal to 0. So actually we're not even interested in that denominator, that horrible looking thing there. We're just interested in this. So when this is equal to 0, so let's take that over to that side. So we've got 4 root 2 sine 2x equals 8 cos 2x. Divide both sides by 4, and we've got root 2 sine 2x equals 2 cos 2x. Divide both sides by cos 2x, divide both sides by root 2. So that's going to, oh wait a minute, sine 2x over cos 2x, that's tan 2x, isn't it? And then I've got 2 over root 2. Multiply top and bottom here by root 2, and it gives me tan 2x equals root 2, which is fantastic because that's what I wanted just down here. Now, there is a part B of this question, which I thought was quite a clever little part of the question. So it's asking me something about the minimum points of a couple of functions down here. First of all, let's work out the minimum point of our function, okay, that we started with. Let's do that first of all. Well, because we can do that quite easily. So if we look at this value just here, if we inverse tan, we should get that 2x is equal to, well, it's going to take two values, isn't it? It's going to be equal to, so the first value that you get on your calculator should be 0.955. Remember, it's got a secondary value, which should be 4.097. Okay, remember tan is repeated every pi. So therefore, that gives me two values of x. So that's going to give me 2.048, 0.478. I've just divided those by 2. Remember, it's the x value that should be between 0 and pi. So it's this is the bit that satisfies this condition just over here. Now, which one's which? Well, if we just refer back to the graph, look, the smallest value of x, that's where the maximum is, and q is the minimum point. So therefore, that's the minimum, and that's the maximum point. Right, now let's make sense of our question. So if we're saying the minimum part of our function is 2.048, well, think about what happens if you just when you go and do transformation of graphs. When you get this, you just divide by 2, don't you? So the answer is simply going to be 2.048 divided by 2, and then that will give you the corresponding value. So that gives us 1.024. And then comes to the final part. Think about what's happening. So we're only interested in the minimum point. So actually that 3 is really not going to make any difference at all, right? We're really not bothered about that. Now let's think about what happens here with this minus 2. So if you multiply a function by minus 2, it flips it, doesn't it? All right, it flips it around on a vertical flip. So the min and the max points will therefore reverse. What difference is the minus 2 going to make? Well, we're only interested, well, rather the 2, we're only interested in the location of the x value. So if I were to go and stretch this graph up here, right, this point is still in the same place. And down here, if I stretch it this way, right, this minimum point is still in the same place. Now remember, it was minus 2, so actually what we're going to be having is we're going to have something like that. And the minimum point is still going to be in line with what we had previously with P. So these are swapped around. Which values did we just have? It's going to be this one just here. So the answer to the second part is 0.478. Hurrah!